All right, in this video, we are given 2 points over here. And in the second question, we are given a parametric equation. And we need to determine 2 possible vector equations for these 2 different problems over here. Let's start with taking a look at the first problem. When I'm given 2 points, what I want to do is I want to start by finding my direction vector. I'll start by finding AB. AB is just B minus A, which is -3, 5 minus 2, 1. And then if I subtract these, I'm going to subtract the x components. So -3 minus 2 is -5, and 5 minus 1 is 4. Now that I have the direction vector, I can actually write the equation of this line. So it's going to be R equals, so you can pick any point on this line. It doesn't matter which one. 2, 1 plus t. And then you're going to put the direction vector, which is -5, 4. And then over here, I'll just write t as an element of all real numbers. So this is one possible equation for the line that passes through these points. To come up with the second equation, you can do a lot of different things. There's a couple of different possibilities. For example, I can change the point over here to the second point, -3, 5, plus over here, I'll use S instead of T. You don't want to generally use the same letter when you have multiple lines in one question. And I can put the same direction vector over here, or I can even switch it to BA, which is just switching the signs of these two. So it'd be 5, -4. Then I'll put S as an element of all real numbers. So I could have either changed the point or changed this. I didn't have to change both, but I just showed you that in this case, it's possible to change both as well. Let's take a look at the second question over here. This is given to us in parametric form. So if you want, you can convert this to a vector equation straight away. But in this question, it asks us to first prove that the point -9, 18 is on the line. So to prove that a point is on the line, we sub in the x value for the x component, and we solve for t. I'm going to add 2 on this side. I'm going to divide both sides by -1, so t equals to 7. And then I'm going to sub in the y component over here. And we should get the exact same answer for t. So subtract 4 on this side, so 14 equals to 2t. And then divide by 2, so 7 equals to t. So since the value of t is the same in both calculations, it means that the point -9, 18 is on the line. And now we have to come up with 2 different vector equations for this. I'll just write the first vector equation from this over here. R equals, so my point is just the constants, which are -2 and 4. And then plus t -1, 2, which are just the coefficients of my t values. Now, when I come up with the second equation, again, I could just switch those. I'm still going to use the letter t because the original letter t was there in the original question here, so I have to stick with that same letter. I could change this vector, or I could change the point to -9, 18 as well, because I know that -9, 18 is also on the line. So for this one, I'll only change the point. I won't change the direction vector, but again, you could have changed either one, or even both of them. So that's two possible vector equations for this line here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.